I guess we're ready to start. Sounds like everyone can hear me, and I'm glad everyone could make it. We'll be talking today about the next generation secure computing base. This is a technology, it's part of Windows that was once known internally by the code name Palladium. That's the last time you'll hear me use that word during this presentation. It's the next generation secure computing base, or NGSCUB. And my name's Keith Kaplan. We'll have Ellen Cram up later. Going to start out with an overview, just what is NGSCUB, what are we trying to do or not trying to do with this, what is a nexus, what are the fundamentals of what goes into the nexus, and there will be time to describe how you can write an agent that takes advantage of NGSCUB, and some time to wrap up at the end. The deck is relatively short, so there should be plenty of time for Q&A at the end. Here we have the marketing slide, the official definition of NGSCUB. The main takeaways here are that, for one, it requires new hardware and new software. This is not, unlike so many other features of Windows, this is not something that you can just go out and buy and put on your old PC. This is requiring changes in the processor itself and elsewhere in the hardware, and I'll get to that more in a minute. But this is not something that you will be able to take advantage of on a legacy PC. This is something for new PCs only. And our objective with NGSCUB is to provide more security than has ever been possible. This is not an issue of closing up some of the buffer overruns or things like that in existing versions of Windows. This is all about, are there things that you simply don't do with a PC today, or that particular customers have proprietary hardware, proprietary operating systems to solve special problems, because using Windows either is not as secure as it needs to be, or is at least not perceived to be as secure as necessary for solving a particular problem. So we are offering new kinds of security and privacy in an interconnected world. So when you want to talk about security, of course, the first thing you always have to say is sort of secure against what? Are we solving all the world's problems, and will all criminals immediately turn themselves in tomorrow? Obviously not. So what we have to sort of pick some bar and say that that's as many problems as we'll be solving, at least in the first version. Certainly we'll plan to make it more and more secure as time goes on, as hardware improves and as I have time to write more code. The first attack that we are very worried about is tampering with data. So if you have data secured by an NGSCUB application, or an agent as we call them, that data cannot be modified without the agent, and more importantly the user of the agent, knowing that that has happened, knowing that that tampering took place. We also worry about information disclosure. So those secrets that are written out by these NGSCUB agents cannot be read by other code. That includes other NGSCUB agents, and it even includes the NT kernel itself, excuse me, the main Windows kernel, I should say. Sorry, I'm an old-timer. The main Windows kernel, or even kernel mode drivers in main Windows, cannot access the secrets that are stored or being used in memory by an NGSCUB agent. We also worry about repudiation attacks. This is where someone, say, makes a bad stock trade or some other bad bank transaction that they later regret, and they like to go complain after the fact that, gee, that wasn't me. Prove that it wasn't just a virus that replayed my password and had me place that ridiculous bid on that online auction, or buy that terrible dog of a stock at that sky-high price. We aim to prevent that sort of attack from not really attack, but prevent that sort of problem from occurring for our customers who choose to write NGSCUB agents. And we also worry very much about attacks in which someone can spoof identity. And by this, typically people talk about identity of a user, and certainly we worry about that. But we also worry about the user being spoofed by not knowing the identity of the code that they think they're running. So they type in their password to something that appears to be a legitimate computer, or they carry on some transaction with some remote piece of software that they think is their bank but is not really. We worry about that sort of attack. Now, I suppose this slide, the thing that's most educational about this slide, not so much the attacks we are worried about, but the list of things, the list of bullets that do not appear on this slide. The next slide is not the rest of the threats we're mitigating. One thing that is conspicuously absent here is denial of service. That's really not within our charter, at least for version 1, for IngScub to prevent denial of service attacks. It's assumed that if the person at the keyboard really wishes to pull the plug, turn off the power to the computer, they can still. So there's kind of a limit to what we can do in software, and even with the new hardware that's coming in an IngScub-capable computer, to really prevent all kinds of denial of service. What we will say is, if your agent application gets a chance to run, and if it reads data in, then that data is provably has not been tampered with and cannot be seen by other applications, other untrusted code. It's important also to mention that we are fully aligned with Longhorn. We are a part of Longhorn. There's no time where you would go buy a copy of IngScub. It's not a separate product by any means. It is simply a feature of Windows. And as such, our dates, our release dates, our beta dates, all align perfectly with Longhorn's. So when you get Longhorn Beta 1, Longhorn Beta 2, that will be IngScub Beta 1 and Beta 2, and so on. We are, for version 1, again, sort of, we have to pick a size bite that we bite off only as much as we can chew, and we're very much more focused on doing less and doing it perfectly than taking on too much. So for version 1, as I've said, there's a small set of attacks that we're going to address. There's also a sort of target customer scenario. We are focusing on the enterprise applications. So this would be something written by perhaps an IT group for use by a company's employees. We are not so focused in version 1 on some of the consumer scenarios or even server-side scenarios where we think IngScub might also be useful in the future as we get time to write these things. We're a small team still. So examples of this would be document signing. Back to the non-repudiation issue, or repudiation issue, we think it would be a very useful type of application to write, taking advantage of IngScub technology, would be something that presents a document to the user in a form that the user can read that, say a contract or an offer to purchase real estate or something, and be able to say for sure in court later, the user really saw that contract and the user really clicked, yes, I want to sign this contract, versus being able to say the data maybe was modified on the way to the screen or a virus clicked OK for me. Another application that might be useful, we hope people will write, would be secure instant messaging. And we're all certainly familiar with instant messaging applications, chat applications. And what would be different about an IngScub-capable chat application, and some of you may have seen this demonstrated at WinHEC, is that a secure instant messenger application would make it so that the keystrokes typed by the user would go directly to that secure chat program and come out on the other side, on the other person you're talking to, come out on their computer to a video card that, again, can't be screen scraped. So the information that's being typed, let's say a broker wishes to have a secure instant chat session, instant messenger session with a few preferred clients. I have a tip on this great stock. Certainly, you don't want that message to either be spoofable so that the clients can't tell whether that message is really coming from the broker. And you also don't want rogue listeners to be able to sit in for free and get this broker's great stock tips without paying. Certainly, given our enterprise focus, we would expect to see applications within corporations. If an IT group has a particular application for looking at internal data, for instance, in one of my past lives, I even worked on an application at Microsoft for making the budget. And unfortunately, they didn't let me leave any backdoors in for my salary. But the fact is, there are applications written internally where there's data that needs to be kept very secure. And needs to be secure from information disclosure and secure from tampering. And those applications today are written internally anyway, so these are applications that the enterprise customer has source code to and could easily port to or write in this new NGSCUB environment. And we'll have more on that later, certainly. Might also want to write something for more secure email, so that an email could arrive in some secure form that even most of the code for the email client program can't even read, but that the user can read by something, shall we say, I'll say decrypting it. So we have this funny name, and it is a terrible name, and we picked the name NGSCUB because it was so terrible we knew it wouldn't already be taken. And so far it appears that we were correct, but the name does have some meaning. It didn't just come from nowhere. We call ourselves a secure computing base, and so obviously when you say you're a base, then there must be something built on top of that base. And what you'll see here in this picture, we've certainly all seen these pictures in textbooks of the kind of user mode, kernel mode division among software. And in the NGSCUB environment, you'll see in the bottom, in the kernel mode section, there's what we call the nexus. This is sort of our equivalent of a kernel. We've invented a new word so as to avoid confusion with the main Windows kernel. We call our kernel the nexus. And the nexus has a now built into it. And we're all familiar with the hardware abstraction layer in main Windows. The HAL, well, this is the Nexus abstraction layer, or NAL. But it's built right into the nexus. Now, you'll notice that in kernel mode, we just have this one box, kind of split in two pieces. But it's just the one box. And that's not a simplification for the purpose of the slide. That's really true. There is no other kernel mode code within the NGSCUB environment other than the nexus itself, which is a small piece of code, very carefully written, very carefully code reviewed, and in theory perfect. Only a small smattering of laughter at that. That's great. Bigger smattering for that. And anyway, I know it's early and some of us just got off our planes, but me included. So you'll notice above that we have a runtime library for these agents to call into. Obviously, just as ordinary Windows applications call into various Windows services provided by various DLLs or the kernel itself, these NGSCUB agents have a means of calling down into the nexus. So when an agent wishes to allocate memory, it will call into the nexus to allocate that memory, rather than calling into the NT kernel. Give you some more example of why that's good later. But you see we have various agents across the top, and these are what we hope lots of people go out and write, so that the examples I was describing earlier, those agents such as the secure instant messenger, those would be the ones you see across the top. Probably can't read some of the other boxes in the middle. There's the trusted user interface engine in the middle, which is how you can write these applications that the TUE basically takes care of some of the rendering issues, takes care of fonts and various language-specific issues. And you see a variety of trusted service providers. We call those TSPs that sit just above the Nexus runtime library. And these are pieces of code that might traditionally have been written as drivers in kernel mode, but given our focus on keeping the Nexus, that most trusted piece of code, just as small as we can possibly get it, we are moving some things off into these trusted service providers. You can almost think of them as user mode drivers. An example of that would be there will be an input TSP that handles the communication with secure keyboards, and a video TSP to handle communication with secure video adapters. And this is where we take care of some of the hardware specific, the sort of heterogeneous nature of PC hardware without actually growing the amount of code that runs in NGSCUB's kernel mode. Now, while I have this slide up here, you can also see a few boxes across the bottom. And those are the secure input and secure video that I've already alluded to. Those little dotted boxes mean that those are pieces of hardware that you already have in any Windows-capable machine, but they show up on this picture because they're being enhanced to take care of NGSCUB, or to support NGSCUB, I should say. You'll also see the CPU and chipset in dotted lines. Certainly, you already have those in your existing PCs, but those are being enhanced to run NGSCUB. So when I say that you have to get only new PCs will support NGSCUB software, that's because typically most people, by the time they're replacing a CPU and a chipset and their video and input hardware, that's buying a whole new computer. You'll also see in the middle this new box, the TPM 1.2. That gets a solid line. That's a brand new piece of hardware that was designed by an industry standards body that provides certain services to the Nexus. And that's a brand new piece of hardware that will appear on INGSCUB-capable motherboards. So you saw this picture we had before. Here, we'll go back and show this again. So this is the secure computing base. This is the INGSCUB world, this user and kernel. Now, surely you're wondering, where did Word go? Where did Excel go? Where did all my Windows drivers go? And the answer is, they're still there. And the machine is split, just sort of analogous to the user and kernel mode split that we draw vertically typically. There is what we call the standard mode, which is where the Windows that we know today runs. We call that sort of the left side. And then the Nexus mode we often refer to as the right side. So perhaps later in this talk, or if you talk to us in the booth later this week, you might hear one of us make reference to, oh, that code runs in the top right. This is the picture that we'll be referring to when we say that. The right side being the new Nexus mode, and the left side being the standard Windows. And you'll see that your applications are still there in the top left, standard mode left side, kernel and drivers and HAL and such, all still there in the lower left. So the reason why we're splitting the machine in half like this, sort of virtually, or conceptually anyway, we're splitting the machine in half, is that there are these two conflicting sets of goals for the code that runs on PCs and the people who use those PCs. And this is our way of addressing that. We present the right side as the secure place. Lots of new code that's been recently reviewed, recently written, and verified in the presence of security being absolutely goal number one. And there isn't even a goal 2 or 3. Probably performance comes in at 4. And we have that world, and it's new hardware and all new applications. Yet, of course, all of our customers, everyone in this room, me included, still has applications and things that run on the left-hand side, various hardware devices that will be completely unchanged that run on the left side, and the drivers for those devices that run on the left side. So we have the best of both worlds, we like to say. You have the compatible left side and the extra secure right side. And an example of sort of one of these trade-offs that we have to make for this security is, while we make the Nexus nice and small, that also limits the number of APIs that will exist in the Nexus. And the standard Windows, of course, has a very rich API set, getting richer all the time, and certainly you'll be hearing plenty about WinFX this week. And that is not something that INGSCUB intends to exactly match feature for feature. That's not really our goal. Because we talk about these focused scenarios for when people will write INGSCUB agents, we don't think we need all those APIs. We don't foresee someone porting SQL Server or Excel to run entirely on the right-hand side. That really makes no sense. We have no intent of having enough APIs in the Nexus or the TSPs to make that possible. These programs would still be written on the left as they are today, but perhaps work in concert with a right-side agent. And Ellen will certainly have time to go into that more. So on this left-hand side, you have Windows, and that includes its applications, its drivers. Every virus that runs today continues to run in the presence of INGSCUB. Now, certainly, there are various technologies that exist to combat these things. In fact, I think I recognize some people in the room who work on these products. Not saying INGSCUB makes it easier to write a virus on the left-hand side. It doesn't make it any harder either, in particular. That's just not our focus. Other people are working on that. That's kind of the necessary evil that comes from, we say, we want everything on the left that runs today to continue running. We want that compatibility. And to get that compatibility, we remain compatible with some viruses. So the only time we would expect to see an existing piece of code fail to run in the presence of INGSCUB would be if it did something very strange, that really only a driver could do anyway. Things like moving all the memory from one physical address to another, or turning off paging, putting the CPU back into real mode. This would be a very strange thing for someone to do, and I can say that in our evaluation so far as we run with prototypes, we've not encountered any issues with this. We haven't discovered the following popular app fails to work because we don't let them turn off paging anymore. That just hasn't materialized, and we hope it won't. So in this Nexus, given that we are trying to keep it as small as can be, it is like a kernel in the sense that it is the base upon which applications are built, but it's not a very full-featured one. We're just putting in, at one point we used to summarize this as kind of chapter 1 of your operating system's textbook. So memory management, thread scheduling, thread dispatching, I should say, and I/O management to those devices that agents actually need to talk to. A few security enforcing functions, and of course we have to handle interrupts, some of the sort of maintenance work that you have to do once you enter the kernel business. But it is not a complete operating system. It does not have file systems. It does not have network drivers. We certainly will provide APIs so that the Nexus mode code can encrypt up a packet, send it over to a piece of left side code that knows how to then send that out over the network. Similarly, receive something from the network, verify a signature, and decrypt it. But we're really not taking on the complete operating system problem in the Nexus. And the most important bullet here is that there is no scheduler built into the Nexus. We have the means of dispatching threads, but the Nexus does not actually know which agent thread to run next. It does not make that decision. And we'll come to that in a moment. But again, one more time we'll say this, no pluggables in the kernel mode on the, quote, right-hand side. The only thing that's running over there is that Nexus for which we took a cryptographic hash at Nexus boot time. So what we do provide, I've spent a lot of time talking about what the Nexus does not provide, but it does provide something. It provides a few things that you don't have today for writing applications. And those are strong process isolation, sealed storage, a secure path to and from the user, and attestation. We'll spend more time on each of these, but the big thing is what's attestation? That's probably the least familiar sounding one. And that is our idea where I'd mentioned about you're running this piece of code and you wonder, is this really my broker's trading application, trading agent? Attestation is all about being able to have identity not just for users, but identities for code. You know which code you're running and which code you're talking to at some other end of a network pipe. So strong process isolation. Now certainly since NT 3.1, we've known that what process isolation is, that it's the idea that one application can't read or write to another application's memory. And this certainly is true, and it's present in standard Windows for user mode code, but the fact is there's more and more kernel mode code. Some of it's not so good, some of it's downright malicious. And so to have code protected from other user mode code or have data protected from other user mode code is only solving part of the problem. It's solving a lot of the problem, but it's not solving all of the problem. So when we say that we provide strong process isolation in NGSCUB, what that means is applications, NGSCUB applications, when they allocate memory from the Nexus, the memory that they get cannot be read or written to by standard Windows code, including the kernel itself. And this is one of the things that we need the new hardware for. And if anyone catches me in the booth later, I'll talk to you for hours about how this works. I only got one slide for it, but it took me months. The main idea is we keep an eye on the page tables, and the new hardware is essential for this. We have a secure path to and from the user. I've alluded to this a few times. So keyboards and mice will have a secure path from the piece of hardware into the NGSCUB agent application to send keystrokes, send mouse clicks that cannot later be denied by the user. And secure output, which today is graphics only. So you can send something to the screen and know that it has not been screen scraped and know that it has not been tampered with on its way to the screen. Now, sealed storage is another new feature that your agents can take advantage of. And I worked on the encryption support in NTFS in one of my other past lives. And that's certainly very helpful. That's great if you get your laptop stolen. Now all the data is secure from someone who can't log in as you. But sealed storage solves the problem at an even finer grained level. This is saying, even if I'm logged in, and it's Keith logged in, and I'm running my brokerage program, that program doesn't necessarily need or want to have access to all the data that all my other programs have stored. So sealed storage is back to saying, let's write a piece of data. Your agent might choose to say, when I write this data, I want to be the only agent that can read this data again later. Or if someone else tampers with this data, I want to be the first to know. I want to know when I read this data back in, it's not the data in the form that I left it. And certainly that we will provide APIs to handle the obvious problems that arise with this, like what about upgrading your application? It might well be that version 1.1 of my broker's app would like to see the data written by version 1.0, and we have solutions to that. I'm not a crypto guy, so I can't go into them, but they exist. An attestation is this idea that your agent can know who it is and know who it is talking to. And this works as so many security problems are solved in sort of this chaining method. The agent has a cryptographic hash that's computed by the nexus when the agent is started. The nexus has a digest that was computed by that TPM. That was the new piece of hardware, the so-called crypto chip that I'd said was going to appear on the new motherboards. And that TPM itself was sealed by some key, or can be attested to by some key either created by an IT department or an OEM. So you have this kind of chain of trust. I trust this OEM that they are making good TPMs. Original equipment manufacturer, can we say that? Okay. I trust this OEM to be making good TPMs. This TPM says it's a good nexus. The nexus says it's a good agent. And I've used the word good 3 times in that sentence. Even though it really doesn't say it's a good one, it just says, here's what its cryptographic hash is. It hashes to 437. And it would be up to you to decide, oh, I know about 400 nexus with the hash 437, and that had this terrible bug. Or that's the one written by my favorite vendor, and I love it. That would not be a decision made globally. So I've said that the nexus is like a kernel, and kernels have to boot. I made reference earlier to when the nexus boots, the TPM takes a hash of it. So what does that really mean? You can sort of think of the nexus as almost like a service in the sense that it can start at any time when it's needed. It can shut down if it's not needed and start up again later. And it's most likely that when you get Longhorn on an Ingscub-capable PC, you may find the Nexus is not actually running by default. That's the most likely scenario, that the OEMs would leave the system so that you have to opt in that you would like to run the Nexus. And you might also set it so that you run the Nexus anytime you try to run one of these Nexus computing agents. Obviously, if you are running no agents, you may decide that you have no use for having the Nexus running at all. So I said that there was no scheduler inside the Nexus. I said it was like a kernel except it has no scheduler. And obviously, if we are going to have these multiple agents, and these agents have multiple threads, just like ordinary left-side processes do, someone has to decide which thread to run when. And our answer to that, given that we're not really worried about the denial of service attack in version 1, our answer is to say, we'll let the NT kernel scheduler do what it knows how to do so well, and it will decide which thread to run. And we take advantage of this. We sort of piggyback on the NT scheduler by saying, for every right-side thread, for every top right thread, here I go saying right and left again, for every Nexus mode thread, there is a corresponding shadow thread, as we call it, running in standard windows. And when that standard windows thread gets scheduled, it calls through to the Nexus to get its corresponding right-side agent thread running. And it's just very important to remember that the scheduler's on the left, and it's not a trusted piece of code exactly, so you can't be sure that your agent will ever get to run again. So it would be unsafe to ever write code of the form, well, I'm going to dangle this secret out here for a moment, but I'll get that into protected memory really soon the next time I run. That's not a safe way to write an application because you don't know when you'll get scheduled again, or if. And we certainly do have some basic scheduling primitives so that your various threads within your agent can block on each other. So, here we have quite a long summary, but I guess we've said quite a lot, and there's yet more to cover. And certainly I'll be handing this off to Ellen soon. But if you need to catch me again later, I will be in the booth several times this week. So, most importantly, Inkscape is part of Longhorn. It is not its own product. It's a combination of new hardware and software. Most importantly, at least because I work on the Nexus, I'll say, most importantly, it's the Nexus, which is this new kernel. It lets you write these new applications that we're calling agents. And by writing these agents and relying on the services that the Nexus provides, we can provide trustworthy computing. And when the Nexus is turned off, everything that runs in Windows today continues to run. And when the Nexus is booted, almost everything well behaved anyway, continues to run on the left just as it always has. And the Nexus will run any code that the user tells it to. Simple as that. And now, I'm going to hand it over to Ellen Cram.
Hi, I'm Ellen Cram. I'm a lead program manager on this project, and I'll be talking to you about how you can write an application, or as we call them, agents, to take advantage of NGSCB. So first of all, agents can be written right now in C or C++. We will create a managed environment as well going forward that you can use to write managed code applications in C# and VB. And there are two main classes of functions that we provide. The first thing we do is we have a class of functions that we have secured using NGSCB. These would be things like the APIs that allow you to access attestation or sealed storage, and a lot of the memory access. However, we know that people need to do things with the regular part of the operating system as well, for example, writing out log files. And so we will provide a set of functions that work much like the functions that you're used to today to make sure that you can write what you need to in your agents. Now, when you think about writing an agent, there are a couple different things that couple ways you can architect it. The first one is to look into whether or not you want to build just a simple standalone application, something that perhaps communicates with a few other applications, but fundamentally is just one piece of code. The example of a secure banking agent is a good example of this, where you have a single piece of code that would run entirely on the right-hand side that would enable you to talk to your bank. If you look at something like document signing, however, you may want to incorporate that into an existing application, such as a word processor, in which case you would write a small component of your application, which would go over on the Nexus mode or right-hand side, and keep most of your application on the left-hand side or standard Windows. Now, you may have heard a little bit about Longhorn Manifest while you've been here. We use the same concept. A manifest is simply a document that describes a lot of things about your agent. Whether or not you can debug the agent so that we can prevent people from attaching debuggers to things that you do not want them to attach debuggers to. What version you have so that when somebody does an attestation, they can find out more about your app. And what the individual components of your app are. The other thing that's very important when you think about NGSCB is your policy. So the most important thing is that the policy is set by the machine owner. When you write an application, you might choose to request certain behavior or certain rights, such as the right to use sealed storage or the right to attest. But fundamentally, the machine owner has full control over what can run, what it's allowed to talk to, and what it's allowed to do. Now, we know that some users won't want to set this themselves, so they will go find a third party, such as people go to virus protection vendors today, to get a list of what they have certified as being okay and what they haven't. And certainly users are open to make their decisions in many ways such as that. So some other things you need to know when writing an agent. The first one, and this is a big change from standard Windows, is that agents are monolithic. We have no DLLs. This helps us make sure that when we do an attestation, we are stating exactly which code is running, that the process can't be pulling other pieces of code in that the person who is attesting may not trust. So if you're going to make an application that is made up of different components, you need to use IPC to communicate between them. This is whether or not you're communicating between one agent and another agent, or if you're communicating between an application and an agent. So a little bit about how IPC works. Simple picture, you've got your standard Windows application and you've got two agents. If the first agent wants to speak to the second agent, it simply copies a byte array over to the Nexus. The Nexus puts this in a kernel mode buffer and sends it over to the other agent. We, of course, have detailed APIs that handle a lot of this for you. Similarly, if you want to talk to a standard Windows application, same process, only this time the Nexus sends the message over to the standard Windows kernel so that it can make sure it gets to the standard application. So debugging. One of the reasons that Keith covered shadow processes just a minute ago is because they're absolutely necessary to how we do debugging. So first of all, an agent is only debuggable if it is set as debuggable in the manifest. This means that if I'm doing an attestation, I am your online bank, and I want to make sure that the agent that you're running is the right agent. Another thing I want to make sure that you haven't done is attached a kernel mode debugger to it so that you can alter its behavior. So what I do is I attest to the identity of that agent, and in that is whether or not it is debuggable. I would, of course, check to make sure that debuggable was false, and if so, then I would be willing to talk to it. However, we know that people do need to be able to debug, so you need the ability to set that things are debuggable. So exactly how does debugging work, considering that we know that on the right-hand side, memory is controlled for each agent separately? These shadow processes that we use to schedule are also used in debugging so that we can make sure that breakpoints happen at the right time and you can actually stop the process along with the shadow process. So the cool thing that we have at PDC this week, there is a release of NGSCB on the CDs that you're taking home. It is a part of Longhorn, and it is therefore in the Longhorn CD, and the SDK is part of the Longhorn SDK. The purpose of this SDK is fundamentally so you can get an idea of what it will be like to write an agent on NGSCB. It is not useful for demonstrating the security of NGSCB because fundamentally we are emulating the hardware, as we know the hardware is not available to people yet. But it certainly gives you an idea of what it's like to write not using the DLLs, working with our IPC, and what it will look like to work with attestation and sealed storage. It also covers things like secure input and output, window layering, and that sort of thing. And it will run on a regular box that you have in your office. So what can you do? You can open up Visual Studio, although you must do debugging on the command line or with another debugger. We have simulated sealed storage, so you can see what the APIs for that look like and get used to using it in your application. We have simulated attestation, so you can make a server call and have it attest to the client process. You can use IPC, and then we have the standard APIs we know you need in order to be able to write an application. This developer preview, however, does not simulate secure path and secure price isolation, with the exception of a few little things like the fact that Windows can't layer. So, very quickly in summary, 4 key features to NGSCB. These are the 4 key reasons you would want to write an application for NGSCB. Strong process isolation, sealed storage, secure path to and from the user, and attestation. You can write either a standalone application that uses this, or you can take an existing application and write pieces of it over on the right-hand side. And fundamentally, writing an NGSCB agent will be very much like writing a standard Windows app. There are a few differences around DLLs and that sort of thing, but they're minor. And you can start playing with this stuff as soon as you get home. So what to do next? We have a hands-on lab here at PDC that is staffed by members of the product team. Our developers, our testers, our program managers are there. They are happy to walk you through the hands-on lab. They're also very happy to answer any of your questions. We also have a booth over in the main room where people are there to answer all of your questions. So you can start looking at the SDK. Start building some prototype apps and see what it's like to work with this. Start talking to your vendors about when they're going to provide NGSCB features for you. We also have a very detailed website with lots of white papers, a Q&A alias, there's news groups and that sort of thing up on the website as well. And that's it. Keith and I and a couple others will be around for questions after this. So, or actually, we can probably start with questions now if Keith, you want to come up? So I believe they have microphones set up. So there are microphones set up there, and I think there are a couple other places if you want to come up.
I'll try one. I think I'm just a little confused. Will this prevent someone from putting a keyboard logger on my machines if I build, say, the secure IM application you mentioned before?
Yes.
How?
Oh, well, gosh, I thought I was going to get away with an easy answer there. Certainly when I describe the trusted input hardware, that's certainly the very attack we're most worried about is someone who was at the kiosk before you who installed a keyboard logger program. So
we need new keyboards, not just the TPM function on the motherboard. You need secure keyboards and mice, special.
Yes, that would be among the new hardware. That's why we say this is really something we expect you to use as part of a new PC.
Okay, thank you.
Thanks. Actually, would you mind dimming the lights a little bit so that we can see a little bit better as well?
Oh, right at the end of the question, I was able to see which microphone he was at. It was not bad.
Hi, I have a question. Who are some of your partners, some of your hardware partners for this initiative?
We have a number of valuable hardware partners, and I'm not exactly certain how many of them want to be announced here.
Certainly.
Be conservative.
I'm sorry, did I reveal too much information there? I hate to do that. It's certainly true that there were some INGSCUB presentations at Intel's IDF a month or so ago. So obviously they are among our partners, and maybe that's as far as we should go for right now.
Yeah.
Oh, and Jeffrey from AMD says that he's willing to be announced here. That certainly AMD is another processor vendor, another valuable partner of ours that's working with us on these to provide INGSCUB-capable CPUs.
Hi, I have a question. I'm not implying any guilt here, but I'm sure that Martha Stewart would like to do all her future trades with INGSCUB instant messaging. However, the federal law around securities, 17A4, the spirit of Sarbanes-Oxley, and other things say that many organizations have to be able to audit all interaction between their employees, and you're talking about enterprise applications. How do you keep someone from deploying an INGSCUB application within your organization?
You keep someone from deploying an INGSCUB-capable application. Well, certainly Ellen alluded to. I'm sorry, I'm taking all the questions here. Anyway, Ellen referred to the policy that a machine owner might enforce to say which agents can run on that machine. And remember, when we say machine owner, we're not necessarily referring to the person typing at the keyboard. In the enterprise case, the machine owner is the corporation. It's the IT group. It's not necessarily the person who's sitting there making illegal trades. So hopefully legal trades mostly. So that by setting that policy is how an IT administrator would make sure that no rogue agents are running.
Thank you.
Let me ask a quick question. Your cryptographic service provider model right now requires that you sign all of the CSPs that gets loaded. Are you going to follow a similar model for these agents? And if you do, are you going to actually require vetting of the code by Microsoft?
So, you want me to take this?
Oh, sure. I'll let you take one.
Okay. So we would certainly never have it so that Microsoft could vet all of the code. For one thing, we don't have anybody who's really signed up to read that much code. The goal is that the purpose of signing is truly just to say, this is an application that I have written, and I attest to it having been written by me. And so fundamentally, the person who does the attestation decides whether or not they're willing to trust that agent, or they're not willing to trust that agent based on what they know about it. in no way goes through Microsoft. We have absolutely no control over it.
So my follow-up question would be, the certificates used to sign with, are you going to have any requirements for that? For example, that they be based in the trusted roots?
We won't.
Okay, thank you.
Oh, actually, I'm going to let Mario cover this because he's on the business side. And
Yeah, the sort of what do we plan to do questions are somewhat trickier, of course.
can you hand those to me?
I'm on the product team. On the marketing side, my name is Mario Juarez. The answer to the question is no. There are no inherent requirements for anything to be signed or for any certifications, any certs, or anything to be included in the way that an app gets written. It's just a set of primitives. The way that those things would get implemented would really be up to the application developer and the way that they build and develop the app, and secondarily, whatever policy the machine owner chooses to allow.
Thank you.
Up front?
I have a question about roaming users and recoverability within an enterprise environment. Could you cover those topics?
The recoverability within an enterprise environment, I assume you're worried about the case where the laptop has the TPM in it and the TPM gets forgotten in a taxi, or worse.
Actually, if you could stand by. Thanks.
Or an employee is terminated or leaves or whatever and so forth.
Or the employee is terminated or leaves, yes. Certainly, let's see, this is going to be a bad hand-waving answer because, again, I'm not the crypto guy. But certainly these are scenarios that we're worried about, and we will make sure we provide the right management, the right APIs, the right infrastructure to make that possible. All these scenarios certainly exist. We will somehow solve the problem of backing up your sealed storage such that it can be, depending on the policy of whoever owns the data, restorable to a new machine. And certainly it happens that computers fail to continue working and you like to keep the data.
Yeah, it's important to note we wouldn't have a way necessarily of backing up the TPM ID on the chip, but when we do sealed storage, a lot of times we do keys that are generated from that key, and those may be something that, if we may generate one key, for example, that enables you to back up that key. So we've got a couple ideas that we're just trying to decide between on how we handle that.
See, all computer science problems can be solved by adding another level of indirection. And so here's an example.
Exactly.
I want to understand a little bit more about the relationship between the hardware, the Windows kernel, and Nexus. And let me state it in a way that to show you kind of the question I'm wrestling with. I'm going to make an assumption that is probably wrong, but it'll clarify the question, and that is, so I boot up my machine with Windows and not Nexus yet. Later on, I bring up Nexus. That sounds like Nexus is running on Windows, therefore it still depends on Windows reliability and integrity. And so maybe you can just elaborate a little bit.
The Nexus depends on Windows reliability in that, back to the problem of us not having a scheduler within the Nexus. So if the NT scheduler stopped working, stopped scheduling right-side threads, certainly we would not run again. To the integrity question, I'll say that because of the memory protection that I'm happy to describe deeper offline, what the Nexus does is make sure that the pages that contain its code and its data have no mappings from untrusted code. And so in that sense, the Nexus can preserve its own integrity thanks to the new hardware and software.
Okay, so is it like that the Windows kernel threads on which Nexus runs and bases its own operation, that once Nexus gets a hold of some memory that presumably it had to acquire from the Win kernel, then it's encrypting that memory with keys that are in the hardware that only it knows how to get to. Somehow, somebody couldn't get to those from the Win kernel.
Let's see. You were still right up to the part about the Nexus gets pages by allocating them from the standard Windows kernel and then sets them aside for its own use. The encryption, that's not necessary, and it would be too slow if we tried it. Most likely, it is sufficient, and I can draw the whole proof if you'd like, that as long as you know no left side code has a virtual mapping to the physical page that contains some data you wish to protect, then the data is safe from untrusted code. You don't have to encrypt it in memory.
Okay, and just one last real quick one. So that depends on some CPU level capabilities in terms of process and memory isolation, and are those CPU capabilities yet to come or in the current chips?
It's certainly true that that depends upon CPU capabilities. We get notified, the Nexus gets traps for reloading the base of the page directory, CR3 on the x86, and for various modifications of the page table structures. As for schedules of CPU features, that's not for me to say.
Okay, thanks.
Yeah, Keith? Yeah, I heard a slightly different question than the one that you actually answered, and I wanted to give a better answer if I could.
This is Jeffrey from AMD, for those of you who don't know him.
Yeah, so so the question was something like, there's a chicken and the egg here. We start up the Longhorn, and along comes the Nexus later. Therefore, doesn't the Nexus depend on the integrity of Longhorn? And the answer is no. And the details are that there's hardware support for the initialization of the Nexus such that that connection is broken, and the Nexus has its integrity that's dependent on hardware base, not on the previous code that was running under Longhorn prior to that point. And this is an answer that applies, I think, equally to all of the processor vendors that are supporting this. So I'll give a vendor-neutral answer there.
That was very
that's
good.
From the architecture.
But still, the hardware guy still said there's a hardware solution to the problem. So
that's right.
That's all to be expected.
So, yeah. And if anybody has any specific questions on that, they can see me after, and I'll give you the AMD answer.
Right, and certainly the TPM, in the fact that the special hardware works, the rest of the special hardware works in concert with the TPM to make sure that the Nexus that's actually booted is the one that was hashed. That's another way that we sort of avoid reliance on Longhorn. Say, Longhorn might tamper with the executable that actually contains the Nexus code, but we would detect that. The TPM would detect that. Next.
Okay. Given that the agents are written in C and C++, how do you protect against, for example, buffer overruns from injecting code into the right-hand side?
How do we protect? Well, for one thing, I will say that if the code were to get injected into the right-hand side, it would only affect that process. The process isolation would prevent sort of a general attack. We certainly worry about an agent not so much being attacked even, but being written from day one with the intent of attacking the other agents. Probably the first or certainly the second agent that gets written will be a virus. That's the expectation. The question of how do we help our vendors write secure agents by using languages that certainly are sometimes prone to various attacks, the answer is we eventually will have an API. We eventually will be able to write managed Inkscape agents. And in the meantime, we'd like to say, please read your code carefully. Code carefully. These agents should be small. Given the somewhat small API set, it should be a small enough piece of code that hopefully you'll have time to read it carefully and just have no such attacks for the agents that you choose to write in C or C++.
It just seems like the whole concept of having a secure agent is for naught if you can run any kind of untrusted code, even on accident, inside an agent, because any attestation you could do would be incorrect if somehow someone was able to inject code in there. So you're basically assuming that not only is your secure computing base completely secure, but also that these agents don't have any holes in them as well.
I'll answer that question in two parts. I'll say certainly, given that there are IPC mechanisms for these agents to communicate with standard Windows code, it's a given that the agent does play some role in keeping the system secure. And that's to say, if the agent were just absolutely terribly unsecure, it could just read data out of sealed storage, read its own data out of sealed storage, and broadcast all those secrets out over the network via the standard Windows. So yes, the agent's quality is part of the solution. And I'll also say, back to the specific, if we want to focus on the specific code injection attack, I'll say that we do require that all code pages are read-only and stay read-only forever. That's one of the advantages you have when you have no backward compatibility obligation. And I'll say that we will do a variety of things based on what the hardware lets us do to ensure that all code is always in read-only pages that we put there. Okay. So we'll do the best we can, but we certainly want the agents to be good.
Right. So one other thing is, as we're designing the APIs, we're trying to keep in mind that people do sometimes make sloppy mistakes, and so we're trying to make sure that the APIs make it very easy to write a good agent and make it tougher to write a bad agent.
We take counted strings anywhere we take strings. The zero terminated thing was a terrible idea.
I have two questions. The first is, when you were talking about spoofing identity, you said that it would help the consumer identify that it was their bank that they were talking to. How does the NGSCB do that?
Do you want me to get it?
Oh, I'll let you take this.
Okay. So fundamentally, if I use an application on my machine and I'm able to connect to my bank and my bank has told me that they're doing an attestation, my being able to get at my bank and actually see my funds and that the fact that my funds are correct lets me know that the bank has done an attestation that was correct. Otherwise, the bank would refuse to speak to me.
You could see your funds today without having done an attestation, and you would have no more assurance that was your bank.
Oh, you mean that somebody is trying to spoof your bank?
Correct.
Okay.
Anybody could ask to attest to your software.
Right. So fundamentally, it very much has to do more with testing from the server than it does the testing from the client. There are certainly things you can imply, though, by connecting. So.
The second question was, if you don't have DLLs anymore and you compose applications by communicating between agents, what does that mean for the code identity of an agent that requires 3 or 4 other agents to perform its operations? What is the attestation of that agent?
So right now, the attestation, and I believe this is what it is today at least, is just the single agent. Part of what you're doing in attestation is you're saying that you fundamentally trust this thing, otherwise you wouldn't attest to it. So certainly if that's something that you're worried about, before you attest as a server to anything, you would want to talk to the people who wrote it or examine the code or do something along those lines to see what it does, to check to make sure it's storing its secrets correctly and not just writing them out to plain text, and to make sure that it's talking to code that you trust.
And when we open these IPC channels, tunnels, whatever we'd like to call them, these transports between the two agents, the agent has a chance to see what the code identity is of the other end of the pipe. So just as you would trust that the agent with a particular hash has freedom from buffer overrun attacks, hopefully, you would also trust that it's checking the code ID of the various other agents that it works with. So it's a transitive thing again.
I have a question about sealed storage, and I guess who seals it and how. As a machine owner, and I'll assume that I actually have a machine at some times, it's very useful for me to get data from one application into another. And possibly those two applications are even owned by companies that compete, shall we say, and might actually find it advantageous to lock their own data up so that nobody else, like their competitors' apps, couldn't import it. So who actually gets to set that policy? Can I say, I own the machine, it's my data, I want it to go from here to there? Or does app A lock it and that's it, it's just stuck forever?
I will say that as the owner of the machine, you choose which agents to run. And I assume if this policy, if this agent behaved in a way you didn't like, you would choose not to run it, I hope. Right. And certainly we expect I'll answer the easier case, we assume that these two applications are either from the same company or people who cooperate reasonably. Certainly there will be policy ways to express, I'd like to write this data so that, I mentioned the upgrade case, so another version of the same app can also modify this data or work with this data. You could certainly also specify this set of other applications or this other vendor we will let modify our data.
Okay, but ultimately it's the agent or the agent embedded within the application that sets the policies for what gets sealed and who can get at that data later? The agent can write data that cannot be accessed by code that it doesn't want to access it. Okay, can it set don't tamper but allow read?
Today's APIs don't. You see, this is truly, and I guess this is sort of an overriding answer to all questions is, gosh, would you like it to? This is sort of a break from Microsoft tradition. We're talking about this product or this technology sort of earlier in the cycle. So here's our chance and here's your chance to tell us that there are APIs missing or APIs you desperately hope that we don't include. And here's your chance for us to change it. So I could tell you an answer today, and then when Longhorn comes out, you might find out that it's even better than you'd hoped.
Okay, well, based on my question, I'm sure you know what my opinion is. So.
Yes, you left very little to my imagination. Thank you.
Your attestations seem to have dependencies in that, in the IAM example, not only are you attesting that the IAM application will not give up information, but you have the path all the way to the screen, there won't be any scraping, and you have a path all the way to the keyboard, there won't be any key logging. That means you're also attesting to the keyboard driver, and the video card. My question has to do with updates and revocations. What happens when down the road it's found that, I'm looking around, I see a lot of bags from ATI, wonderful vendor, but let's say there's a bug in one of the revs of one of their cars, which would allow screen scraping. How do you revoke the information about that particular rev of that card and have applications learn about that?
Well, you say, how do you, and I don't do the revoking, but I'll answer, but seriously, but your question is a good one. Certainly. It's when you write, let's say that you are the back end of this chat server, you might decide on Monday that when I see the attestation is this particular nexus or this particular input trusted service provider, I will open conversations with that person. Tuesday you find out about the bug, and Wednesday that same person tries to log in, and you, as the keeper of the back end, might not let that person connect on Wednesday.
But does that mean that every single owner of every single back end has to know about every single flaw?
Certainly policy decisions can be delegated.
Okay.
And so certainly, right, I wouldn't expect every small vendor to know of every bug, and this is why, as Ellen alluded to, the fact that there are people today in the business of knowing which code is a virus and which code isn't. There hopefully will arise third parties. Anyone in the room who wants to make lots of money, please jump on this. There will arise services, perhaps, of keeping track of that, keeping track of which keyboard turns out to have a bug, or keyboard TSP turns out to have a bug.
Thank you.
Hi. I had a question about possibility of multiple policy owners. For example, if I have a PC that I used to play movies and somebody wants to make sure I only play movies I paid for, and at the same time I'm running the client application for a brokerage server app, and my IT guy wants to make sure that I don't screen scrape the data that's coming from a brokerage server. Would I need to have two PCs for that, or there is some kind of negotiation that can go on between provider of two services?
I'll say that if you have these two different agents and they both have opinions about that sort of let's stick to the video example of which video TSP they'd like to work with, that would be hopefully it will be the case that there aren't that many video TSPs out there. Hopefully they're just a version or two of each of the major vendors. There aren't that many vendors left, for better or for worse. And so hopefully that means that it won't be that hard. It's certainly my expectation that you should easily be able to find a video TSP that your broker and that this other application you referred to would both like. And I hope that that problem just doesn't exist. If it does, certainly you could boot different Nexus, boot different TSPs to run those different things. I can't imagine a scenario where you would have to resort to actually buying two different PCs to do these two different things, unless it turns out that it really is a hardware bug. Hard to predict.
Do you plan to bring the right-hand side and the .NET Common Language Runtime together?
Do we intend to bring them together? And we certainly intend to provide the CLR, the Common Language Runtime,
I'm looking
on the right-hand
for
side.
certified Common Language Runtime executor or interpreter, or what you think, so I can execute .NET code from C# or Visual Basic directly on the right-hand side.
That is certainly a goal. It's just when you say, are we integrating the CLR with Inkscape, I certainly don't mean to imply, because this is not remotely true, that there won't be CLR for the left forever. I'm just saying that certainly we would like you to be able to write your agents, manage code, C#, Common Language Runtime, all that good stuff.
It would probably be a TSP that you saw in the diagram. That would be over on the right-hand side. That would be a version of, probably a smaller version of the CLR, something that we can make sure is completely secure. It would be separate probably from the left hand, at least at first.
Anyone? Go for it.
Hi. What about the use case of using existing hardware tokens? So have you thought about putting the TSB, is it,
right,
into a SIM card?
Oh, the TPM, you mean the crypto chip, the Trusted Platform Module, putting that into a SIM card?
Yeah.
I will say that, what do I want to say? For a variety of reasons, it is our hope that the TPM is associated with a motherboard in a way that is, it doesn't, for our scenarios, we've not identified a case where it would be very helpful to be able to swap that in and out frequently. In some cases where it would be more advantageous to know that you can't. So
But then you have the same user portability.
Certainly,
if it's in the motherboard and not on a SIM card.
certainly, so if you wanted to carry your TPM with you and then whichever computer you went to, not my question to answer. That's an interesting request.
Why can't this be both my memory and my write?
Mario would like to speak to that.
The primary reason for it is that we want the TPM to just stay on the box because it is just there to be associated with this environment and to verify, be the hardware root, if you will, for what's happening in this environment. You're still going to want, probably more likely than not, the kinds of functionality that you would get from a portable smart card that would be associated with your identity. You're still going to want to use that. But having it rooted to the machine, having it rooted to the motherboard provides a lot of advantages that are specific to the maintenance, the integrity of the box itself. We're not trying to supplant functionality that would come from a card that you would intend to be portable, and we see advantages to keeping it pretty secure on the box.
Question, help me understand a little more about auditability or auditing and accountability of a mixed left-right application. Obviously, you can't depend on the left side for any final non-repudiation in this environment because that's what the right side is all about. So would I view it, would it be correct to view it this way, and if not, you can correct it, but to say that the right side, Nexus, et cetera, is keeping its own secure logs, to the file system in some way or another, and anything that I log on the left side is sort of a helper to get me to the right place of the real audit logs on the right side. That fair way to think about it, or are there even audit logs on the right side?
I would say that's a perfect answer to this and to a number of other things. That for data in general, I would say for some large amount of your data, store it in main windows on the left side, and for some small amount that you're very worried about having it tampered with, have that written by right side. And that applies to logs, that applies to any data.
Actually, a good example of this is the document signing case. When I'm writing the document, it makes sense for me to use a full-featured word processor. And when I'm writing, for example, the sale of my house document, the big contract, I can go ahead and use this in the word processor because I'm not worried about somebody seeing it or something like that. However, when I want to view every single detail about it and I want to sign my name, I want to make sure that I saw what I actually saw and it wasn't spoofed, and that when I sign my name, I really sign my name so the other person can know. So in this sort of case, you're looking at, there are lots of things that can happen on the left-hand side that make complete sense. There is no risk. It's when you're doing a particular task that takes advantage of one of the four features is when you want to really look at moving it over to the right.
So in that case, the left side would pass a handle to the right side as the screen that I'm dealing with or whatever, and then it could completely on the right side display the document for digital signing on a trusted screen with a trusted keyboard, et cetera, and then store its documentation of that transaction and then a reference back to the left side that then it could
Basically, the PC you have running on the left-hand side would need to package up all of the data that you've built up, the contract, send it over IPC over to an application or component running over on the right-hand side. That would show you a viewer, a window that another window can't move
Right.
over, that you
Right.
can actually read and be sure. In that case, you know that you've got the keyboard and the video card that are secure. And then that's where you do it. And then it would package it up and sign it based on, yes, they really saw it, and the left-hand side could access that. Yeah.
And in that secure storage example that you said, it really is just secure storage, because if I store it on the right side and then pass it back to the left for an integrated display, I lost control of it, right?
Yeah, certainly if you have data that you really want to seal with sealed storage, you may never want to move it to the left in that condition.
Yeah,
Somehow
you're back to the special viewer kind of scenario.
Exactly.
Okay, I see. Thanks.
I think we're going to get the hook pretty soon here, correct? Probably time for one or two more.
Yeah, I just was wondering how the Nexus fits into the environment. I imagine that when Longhorn ships, you guys will ship a Microsoft Nexus. Are other vendors able to write their own, and would there be any reason for an agent to require that it runs in a certain Nexus?
Again, I guess I'll stick to, given that we keep using the Nexus as being analogous to a kernel, are there other vendors that write operating system kernels? Certainly. Are there applications that require certain operating system kernels? Certainly again. So will other people write Nexuses, and will there be agents that require a certain Nexus? I assume that's every bit as likely.
A couple things to note. Just as a side note, only one Nexus can run at a time. I don't know if that was made clear in the presentation. There are licensing issues. Your question implies what are the licensing terms. We're working on those now. We will have an announcement. I don't even want to be nailed down, but I can tell you that there's a lot of work going on inside the company now to figure out what are the terms that are going to be offered to other operating system vendors. By virtue of a lot of factors, some of them legal, some of them business-driven, we have to do that, and so we're focused on doing that now, but we don't have those terms available for any kind of public discussion at this point.
And secondly, how powerful will the user interface engine be?
How powerful will any of it be? As powerful as it needs to be, and not 1% more powerful, because every line of code is a potential bug, and we want this to be perfect. Is that a terrible hand-waving answer?
A little bit, yeah.
But I think you can probably infer from the scenarios we've described sort of how much we think we anticipate people doing with the UI for an agent, and that's how much functionality there will be. Will you want to port your exotic 3D CAD application to rely on the TUE tomorrow? No.
Definitely also play with the SDK that we give out now. And send us in feedback about what you see missing from the user interface that your applications depend on, that you would want to write on the right-hand side, because we still are at a point where we're gathering some data on that.
Okay, cool. Thank you.
Thank you.
I think our time is up. Oh, okay, one more.
So quickly, my question, maybe it's a tirade, has to do with terminology. I think the three ago, the question on SIM cards, that you're trying to draw a distinction between the authenticator and the authentication. This would be the authentication that would use NSCUB and the onboard processing to be authenticated. So you would carry the authentication credentials plus presumably biometrics around, but it would only be allowed to run, in that case, on the authenticated platform.
We are considering some issues, some scenarios like that.
To separate data from code, essentially.
And the idea of you carry something that can, we talk about the attestation of this remote server. Is it possible that the remote server that does the attestation is actually in your pocket, so that the mall kiosk scenario, you can sort of tell, should I trust this computer at some public location? And certainly you might carry some device that could do that sort of challenge response.
And then a plea on nomenclature. Please tell me that left-hand side, right-hand side, and NSCUB have not been permanently ingrained in granite, and there will be better, more euphonious names that can actually be used in business meetings with people with ties.
The names can only get better from here.
That's certainly true.
I promise.
Thank you.
Thanks, everyone.